back for week 5. Great to have you on this amazingly wonderful day. Beautiful weather outside. We're gonna get going in about a minute's time. So until then, we'll just make sure you got something to drink with you. Stay hydrated. Very hot today. The slides that we're using are available in the link in the description as well if you want to print them out. You can also sign up to our mailing list. We'll email you the slides and the link to the lectures afterwards. Click on the link in the description, hit register, and we'll get you signed up from there. Hi Haley, hi Josh. Welcome back, great to have you guys back. Okay. Welcome back for week 5. We're looking at further algebra today. That's really polynomial long division, factor theorem and remainder theorem. I'm going to turn my camera off now so we can get going into this. So as always, we'll go over the rules and then look at some of the applications. Get in touch in the live chat if there's anything you want me to go over, anything you're not sure about. Hi Breed, thanks for tuning in. Also get in touch with us anytime. Use the email address there, number there. More than welcome to get in touch with us anytime if you need help with your maths. Like we said, as always, if you're going too fast, pause the video, catch up afterwards. There's more problems available in the description. And as always, feedback is welcome. So we're going to look at 3 specific areas today, like I said. It's really crucial that you have a solid understanding of topic 1 and the algebra involved there before we go into some of the work we're looking at today, particularly things like the discriminant, simultaneous equations, quadratic simultaneous equations, and general familiarity with polynomials, quadratics, cubics, quartics, things like that. But we're gonna recap some of that stuff today as well. It's only 3, should be quite a short lecture today actually, so we might even get done in about an hour and a half's time, but we'll get going and see where we go from there. So polynomial long division or algebraic long division, I just want to draw some parallels here with normal long division. So normal long division, right, what we're going to say is, well, how many times does 4 go into 3? Well, that's going to be 0. And then we're going to say, well, how many times does 4 go into 34? That's going to be 8 times. 8 times 4 is 32. 34 take away 32 is 2, and then we're going to bring the 4 down. And then we would carry on solving like this, right? So we get 24. How many times does 4 go into 24? And so on and so on. And this is exactly the same for polynomial long division. Algebraic long division is sometimes called. But they both mean the exact same thing. So here we've got our algebraic function. And what we're asking is, well, how many times does x plus 2 go into x cubed? Or really, actually, the question we want to ask is, what would we have to multiply this expression by, the x plus 2, to make it look similar to this? If we multiply x plus 2, by x squared, this is then going to become then minus x cubed plus 2x squared. Well then, my x cubes are going to cancel out. 5x squared minus 2x squared is going to give me 3x squared. And then I'll bring down this 4x plus 4x. And we're going to ask that same question again. What do I need to multiply this expression by here in order to get from x plus 2 or x to 3x squared? And clearly we're going to have to multiply this by 3x. So the 3x goes up top here. And we're going to get minus 3x squared plus 6x. That's going to cancel there like last time. 4x minus 6x, sorry, is going to leave us with minus 2x. Bring the minus 4 down. To get from x plus 2, minus 2x minus 4, we multiply by minus 2. So we're going to get minus 2x plus 4. These are all going to cancel. So we're left with a remainder of 0. So we know that this cubic we started off with can factorize once into x plus 2 and x squared plus 3x minus 2. So we get x plus 2, x squared plus 3x minus 2. Okay? This is only partially factorized, however. Right? This is a really crucial point. This is only partially factorized because we've still got a quadratic term here. And in fact, to this quadratic term in this specific case, can't be factorized. Okay, this can't be factorized. So actually, this is as far as we can go. This is as far as we can go. So in this case, we're fully factorized, but we have to be careful that in general, if we end up with a quadratic here that can be factorized, we would also be asked to do that. Okay, so as normal, I'll give you this question on the right hand side here and let you have a go at that. Okay, so I'm just going to start working through the solution. If you're still going, don't worry. I'm not going to give explanations this time. I'm just going to show you the working. One important thing here is we don't have an x term. Right? This is 2x cubed plus 3x squared, and no x term minus 1. So what I'm going to do is I'm going to add in plus 0x here. And the reason we're going to do that should become evident in the next step. So this is going to become, to get from x to x squared, we're going to have to times by x. So this becomes minus x squared plus 1x. And we can see if I didn't have this 0x here, there's nothing to subtract this x from. So this 0x just allows us to have something that we can subtract away from. So we end up with minus x. I'll bring the minus 1 down here. End up with 0. So we get this as our final answer. So I'll give you just a few moments to get that copied out, make any corrections you need to make. The key thing here is understanding this 0x. Right, that's the difference between these two questions. is we've added in 0x there. And it just makes our working a lot easier to work out. And again, this quadratic can't be factorised further, so this is factorised as far as possible. Okay, this cubic has been factorised as far as possible into these two brackets here. I also want to highlight what getting this remainder of 0 means. The remainder of 0 is very significant, and we'll go on to later looking at why and some applications of that significance. But it's significant because what it means is that this bracket, this expression, goes fully into this one with no remainder. So this is a full factor of this expression. This is what that means. If we didn't end up with a remainder of 0, then this would not be a factor of our polynomial expression here. Okay? So let's go on to the next question then. So again here we see, I'll give you a second to read that question first. So we can see there is no x squared term here. So before I start working this out, I'm going to write my working as x cubed plus 0x squared minus 3x minus 2. And then I'm going to go through and do the algebraic long division. Okay, so I'll give you about half a minute to go through and have a go at that, and then I'll start writing up the solution. Okay, so I'm going to start writing up the solution here. Don't worry if you're still working. So we get this as the first bit of our answer from the long division. But there's a hint in the question here. It says completely factorize our cubic, and that wording is quite intentional, and it should set off alarm bells thinking completely factorize means there are going to be more steps involved after the division. So we can see that this quadratic can also be factorized. So if you haven't factorized that just yet, I'll give you a moment to go through and do that, and then I'll write up the solution in about 20 seconds time. So we should get x minus 2 here, and then this is going to factorize x plus 1, x plus 1, So we can write this simply as x minus 2 like this. Okay? So this is very similar to the previous two questions we looked at, just with this added step of factorizing the quadratic, we also get left with. Okay? But this is really all there is to algebraic long division, polynomial long division. Right? This is just all there is. And it's just a technique that we can use. But in my opinion, its real power is how you can use the understanding behind this technique. Long division can be a bit laborious. So actually there's quicker ways to do some of the, to use the principles to reach some of the same conclusions. So this is what we're going to do now, and we're going to look at the factor theorem. And I'll give you a second just to read this sentence and get it copied out. Let's give a concrete example to this as well. So let's say we have f of x is equal to x squared plus 5x plus 6. So now we can factorize this as x plus 2 is x plus 3. And then what this is saying is that if we were to substitute in the negative of either of these two values in our bracket here, we would get 0. Our function would become 0. So this is what this bit here means. F of a, where a is our value in here, but crucially you can see a is positive here and negative here, or it can be positive here and negative here. It's just the negative of whatever's in the bracket. So let's test it. If we were to plug in f of minus 2, this is going to give us minus 2 squared plus 5 times minus 2 plus 6. Well, this is 4. 5 times minus 2 is minus 10 plus 6. We can see that this is definitely going to give us 0. So this is the point that we're making here, that there's a link between these two bits, right? The solution, and this is the proof, right? So factor theorem is saying, well, this is the proof. If this is true, if f of minus 2 does equal 0, then we can say, well, x plus 2 must be a solution. Okay, so we'll get some more examples to that. So this is use the factor theorem to factorize as far as possible. This is something, I'll give you a second just to copy this out. So this is something that is relatively new to your specification, in that they may just give you an expression like they have here and say, factorize this. They may not give you a starting point. So sometimes they'll say, knowing that, like we had in the question 2 slides ago, so given that x minus 2 is a factor, factorize this. They may just give you, like they have here, a polynomial expression or equation and say factorize it. And at that point, what you have to do first is start choosing numbers. So let's choose f of 1. Well, this is going to give us 1 cubed minus 7 minus 6. Well, clearly, that does not equal 0. So we know that f of 1 is not a solution, and therefore x minus 1 is not a factor. So let's try f of minus 1. This is going to be minus 1 cubed minus, minus 7 times minus 1, subtract 6. So this is minus 1 plus 7 minus 6, which does give us 0. So we can now say, well, therefore, x plus 1 is a factor. Because we've got this 0 answer here, we take the negative of what we plugged into our function and say, well, that is a solution, a factor of our original expression. And now this is where we adapt long division and use the principles behind it. We know that if we were to divide this cubic up here by this, which is a linear factor, we have to end up with a quadratic. Right? It's the only way we can get back to a cubic. So what we can say is, well, therefore, f of x is equal to x plus 1, because we know that's a factor, we've proved it here, multiplied by ax squared plus bx plus c, some quadratic. We don't know what the quadratic is yet, but some quadratic. And at this point, what we do, compare coefficients. So what we say is, well, our original function has 1x cubed. The only way we can get 1x cubed from expanding these brackets is if a is equal to 1. Because we'll get ax cubed, and that's the only cubic term when we expand these brackets. Therefore, that has to equal x cubed. So let's just write that out. We can say, therefore, ax cubed must equal x cubed, and a equals 1. We can then do apply a similar logic to find c, right? The only constant term will be 1 times c when we expand this out. So we can say, well, 1c, in fact, let's just write that as c. C is equal to minus 6, it has to, because this is the only constant term in our original expression, minus 6. So we've got A, and now we've also got C. B is slightly more difficult. When we expand, I'm just going to move this question up a bit. When we expand this bracket, these two brackets here, we'll get 2 x terms. We'll get 1 times bx, so bx, plus c times x, plus cx. And this must sum to give us minus 7x here, right? Because the coefficients must match. X and x here must match the x coefficient up here. Must add up to minus 7x here. And we're just going to cancel through the x's. We've already worked out what c is, so we can sub that in. So we get b minus 6 is equal to minus 7. Therefore, b is equal to minus 1. So now we can go back up here and rewrite this polynomial. We can say, therefore, f of x is equal to x plus 1, x squared minus x minus 6. And then we have to check, can we factorize this quadratic further? We're going to get x plus 1. And just by looking at it, I know this is going to be x minus 3, x plus 2. And now we've fully factorized our quadratic. There's no guarantee this is going to be factorizable. The question says as far as possible, but we have to check. Okay, we have to do that check. So that is now fully factorized. So I'll remove this block at the top. So we've got another question up here. I've given you a hint because I didn't want you spending ages trying numbers. So start off with f of minus 3 here, and then use that to go ahead and factorize this. So I've just started off some of the working up here. Showing why x plus 3 is a factor. So now we can split this and say, well, this is f of x is now going to be x plus 3 multiplied by some quadratic. And then we're going to go through the blue steps on the left hand side, very similar to the blue steps on the left hand side, and go through and find our values for a, b and c. Just a quick note, here where we've used bx and cx, I could also have used this x squared terms, right? So we could also have done the same comparisons for x squared terms and just use 0x squared up here. There's no difference, it doesn't make a difference what ones you use. So you can use the x terms or the x squared terms as long as you're consistent. So I'm not going to show the working for some of these, I'm just going to give you the values. And we should get, so those are a, b and c values on the screen now. So we can write, let me give myself f of x is equal to and that cannot be factorized. That cannot be factorized. Okay, so that is as far as we can go. Let's just check. So let's check this minus 4, no problem. So what I'm going to do is I'm going to equate my values, my x coefficients. When we multiply out this f of x here, the x coefficients are going to come from cx. So I'm going to go through it down here. So cx and then 3bx, right? 3bx. Those are going to give me my two x terms. And I multiply out these double brackets here. And that has to equate to minus 11 from our original, minus 11x from our original equation up here. C we've already said is 1. So if I divide, first I'm going to cancel through my x's. So I end up with 1 plus 3b equals minus 11. And then from here, we rearrange to get the value of b, which will come out as minus 4. So we'll get 3b equals minus 12. Therefore, b equals minus 4. So let me know if that clarifies things. If it doesn't, let me know and we'll try a different way. So this is an alternative method for algebraic long division. This is my personal preference, but that doesn't mean you have to do it this way. If you can also, so once we've got to this point and we've established a solution, in this case x plus 3, I could also have done algebraic long division and just done this f of x here, divided by x plus 3. Right, and we would still get to this point. So this is, there's no, I think this is a simpler way by comparing coefficients, but if you prefer doing algebraic division, if you're more familiar with that, there's no reason why you should do this, okay? But if this helps, this is just a different way of doing it and using the mathematical knowledge we have. So you're welcome, guys. I'm glad that helped. Okay, so let's look at an exam question now. So down here we've got a very typical exam question. I'm just going to scroll this up. So I'm going to give you just some time to read through this. And then once you've had a read through, have a go at the question, and then I'll give you about a minute, and then we'll go through the solution together. So I'm going to start going through this first answer here. So this is the first part of question A here. I've subbed in f of 1 and shown that we get 0 out. And I made the statement, therefore, x minus 1 is a factor. And then I've created my general cubic here, ax cubed plus bx squared plus cx plus d. And now we're going to use the same ideas to go through and find a, b, c, and d around comparing coefficients. Again, we could do polynomial long division. It's just personal preference. Straight away we can find that a is 1 and d is 10, because they're the only way we get 1x to the 4 and negative 10 when we multiply these out. So I'll give you some time just to... B and C are not as straightforward this time, but the principles are still the same. Okay, the principles are still the same. So collect your coefficients and common terms and equate them. So what we're going to get, when we multiply this out, when we multiply these two brackets here out, our cubed terms, we would get bx cubed minus ax cubed, and that would have to equal minus x cubed. So again, let's just go through, we can cancel out the x cubed. We've already worked out that a is 1, so we get b minus 1 is equal to minus 1, and therefore b equals 0. And then we do the same thing for c. So if we work out, we can work out all of the x terms that we would end up with when we multiply this out. We'd get dx minus cx, and that must equal 9x. So again, let's go through, cancel out the x's. D we already know is 10. So 10 minus c is equal to 9. Therefore, c equals 1. So now we can say f of x is equal to x minus 1 multiplied by x cubed, b is 0, so there's no x squared term, plus x plus 10. A is 1, because when I multiply these two brackets out here, the only way I can get an x to the 4 term is x times ax cubed, which will give me ax to the 4. This is the x to the 4 here, so a must equal 1 in order for those coefficients to match. So we can now see that we've got our linear factor and our cubic factor here. Let me know if that makes sense or not. Otherwise, I'll go through it again. Otherwise, we've got our linear and cubic factor here. So now we can go on to part B. You're welcome, Breathe. No worries. What I would do at this point is, this is again, we're having to just guess and use certain numbers. But what I would do is, if you've got either a graphical calculator or a calculator that can solve polynomials for you, is I would plug this polynomial in so you can get the solution and then work backward. For example, I've plugged this polynomial into my calculator and it tells me that that x equals -2 is a solution. So what I'm going to do is show that and say, well, let's plug in f of -2 into my cubic, because that's all we're now trying to do, is solve our cubic. And we're going to get, in fact, let's not confuse things. Let's define this as a new function. So let g of x equal x cubed plus x plus 10. And then we get g of -2, -2 cubed, -2 plus 10. And we can see that's going to equal 0. So therefore, x equals -2 is another root of f of x. And now here we're going to use this for part C as well, which is factorize fully. And what I would do here is I would factorize g of x as if it was a separate function, and then put it back into f of x by adding in this in later. So what I mean by that is, we'll say part C, g of x is going to be x plus 2 times some quadratic. So have a go at working out the values of a, b and c there, and then I'll write up the solution in about half a minute's time. So you can see at the bottom here, I've got my values for A and C, and also now B. So putting this all together, you say therefore f of x is equal to x minus 1, which was our original factor, x plus 2, and then using the values of a, b and c that we've just found, let me scroll this up, we're going to get x squared minus 2x plus 5. Okay. So here we've got our two real roots. The question, the second part of part C is, show also that f of x equals 0 has only two real roots. We've already got two real roots here. So now what we're trying to show is that this bit does not have real roots. And remember, when we did lecture 1, we said that this wording, real roots, should set off alarm bells of using the discriminant. Whenever we see this wording about real roots, we should be thinking discriminant. So what we need to do is work out the discriminant of this quadratic bracket here and show that we don't end up with any real solutions for that particular bit, and therefore the only roots we have, real roots that we have, are the ones we've already found. So I'll leave you to go through and do that. Okay, so don't worry if you haven't finished that just yet. You can go back and finish that in your own time. Just make a note of what you need to do to prove the number of roots that are available. And let's look at this question. So again, I'll give you a second just to read the question. If you haven't got the sketch down or the slide printed out already, just get the sketch copied out very quickly now. Breathe. What I will do is let's go through these questions and then I'll go back to part C at the end of the lesson, if that's okay. So, the question tells us here that it is a cubic. So we can say straight away that f of x is going to be equal to ax cubed plus bx squared plus cx plus d. And actually we've already got our three solutions here, right? We can already say, well, this has to be x plus 2, x minus 3, and x minus 5. But what we don't know is if there is some kind of multiplier outside here. So we write that constant in as a. We don't know if that exists or not. And the way we work out this value of a is we say, well, we know the y-intercept here is 60. This d term here is going to be 60. And the only way we get d is multiplying by all the constants multiplied together. So therefore we can say therefore 60 is equal to a multiplied by 2 multiplied by minus 3 multiplied by minus 5. So what we get here is 60 is equal to 30a, therefore a equals 2. So we can now say therefore f of x is equal to 2 brackets x plus 2, x minus 3, x minus 5. We could go through and multiply these out, but there's no real need to, so we can leave that as it is. Okay, so have a go at doing this question here on the right hand side. Make sure you get the sketch drawn out as well, just so it makes sense. So again, we know this is a cubic. We know also that the solutions are going to be, there's a repeated root at minus 2, so that's going to be x plus 2 squared, and there's another root at x equals 1, so we've got bracket x minus 1 there. And again, we're going to use now this y-intercept. So we're going to get minus 4 is equal to and we get a solution there. Okay, so it's really important to remember this a constant term out here and what that means and how we can use it. Right? We don't know if there is or is not this a term. So in this case, a is 1. We end up with just a cubic. Here a was 2. We have to account for that. Or you always account for it and then solve afterwards. Okay. So what we'll do is we'll have a very short break here. I make it 11:56, so we'll say back at 12:05. We've only got remainder theorem to go, so it shouldn't take too long after that. We'll have a very short break now. But what I'll do is during that break, I'm going to go back to part C on the previous question and just go through that part again for anyone who wants to look through that. So if you want a break, back at 12:05. Otherwise, stay tuned and we'll go through part C for this question here. So let's just take a second to read through this question again. So question C has two parts. First, factorize f of x. Once that's done, show that f of x has two real roots. So what we've done here is, initially in part A, we've got these two factors. We've got a linear factor and a cubic factor out here. And what we then said was, for part B, we said, well, let's just ignore this linear factor and just focus on the cubic factor. And we'll call that g of x. Right? But because g of x has come from f of x, any factors of g of x will also be factors of f of x. The way to think about it is g of x is a part of f of x. Okay? So when we've factorized g of x here, we know that x plus 2 is a root from part B. And then we've compared coefficients here. So g of x, let's make it really clear. So g of x is equal to x cubed plus x plus 10. So what we're saying is when we multiply these brackets out here, we should get back to this expression here. We multiply these two brackets here, we should get back to this expression here. So therefore a must be 1 because x times ax squared is equal to 1x cubed, so a is 1. The constant term will be 2c, and 2c must be equal to 10, therefore c equals 5. And b we then work out, like we did previously, where we work out, let's say, in this case, all the x terms. So we get 2bx plus cx is equal to 1x. And we rearrange to work out b. So what we then say is, well, then g of x equal to x plus 2 times x squared minus 2x plus 5. And like we said, g of x is a part of f of x, right? Like this bit here is g of x. So we can rewrite f of x as x minus 1 and then x plus 2, x squared minus 2x plus 5, which is what we've done at the bottom here. That's what we've done at the bottom here. Okay? So that's that factorizing bit shown. We've factorized it, showing two linear factors. These are our linear factors here. The second bit of showing that it has only two real roots is where we then take the quadratic, and we've already stated a equals 1, b equals minus 2, and c equals 5. And we're going to use the discriminant and plug our values in. So we get 4 minus 4 times 1 times 5, which is 4 minus 20, which is going to be less than 0. Therefore, there are no real roots for the quadratic. So our final statement is, therefore, the only real roots of f of x is x equals minus 1, x equals 1, positive 1. Let's just do that again, shall we? X equals 1 and x equals minus 2. Okay, so hopefully that clarifies it. Let me know in the live chat if it doesn't, and I'll try and think of another way of going around it. But essentially, the way you want to think about it, there's two bits: the factorizing and the proving of real roots. So the second bit down here of using the discriminant here, that's the proving of the real roots, and this is the factorizing bit up here. I'll leave that up for a little while though, just to so you can have a look through. You're welcome, Breathe, no worries. And then we've got another 3 minutes and then we'll get back. Okay, welcome back. I hope you guys had a chance to get something to eat and drink and have a quick break. There's not too much left today, it's a very short topic. So we're on to remainder theorem. I'll give you a second just to have a read through the sentence and get it copied out. So again, let's try and make this concrete. Last time we used this example, f of x is equal to x squared plus 5x plus 6. And we said if we factorize this, we'll get x plus 2 and x plus 3. Or in other words, if we were to divide x squared plus 5x plus 6 by x plus 2, we'd end up with x plus 3. And we also said, well, if we were to sub in f of minus 2 or f of minus 3, we'd get 0. What remainder theorem says is, let's say we took f of minus 4 and we substituted this in. So we get minus 4 squared plus 5 times minus 4 plus 6, which is going to be, so we get 16 minus 20 plus 6, which is going to be 2, right? We get this value of 2. So what this is saying is that if we did x squared plus 5x plus 6 divided by x plus 4, we'd end up with this remainder of 2. We'd end up with remainder of 2. This is what this bit up here means. That is what the remainder theorem is saying. Okay? We'd end up with this remainder of 2. So we can use that knowledge to then work out some other bits and pieces. So for example, I'll give you a second to read through this question. And get it copied out. So, what we're saying is working out this, remainder theorem is saying if we were to do this polynomial long division, we'd get some answer, either 0 or some remainder. But we can skip that step by saying, well, rather than doing that, let's find f of 1. Let's find f of 1. If we get f of 1, we get 1 plus 3 plus 4 plus 1, which is 9. So we know we get a remainder. We know this doesn't factorize fully. And this is really useful because what it tells us is we can't use the comparing coefficients method. Right? We can't use the comparing coefficients method that we previously did. We would have to do algebraic long division. To work this out, we'd have to do algebraic long division. So I'm going to give you guys about a minute to go through and have a go at doing that long division. So you can see here, I've just finished off doing this long division, and you can see this remainder of 9 that we get here. So what this means is, what we're trying to say is, we can rewrite f of x as x squared plus 4x plus 8, so this expression we've got at the top here, plus 9 divided by x minus 1, right? Just like we would do for numerical rate remainders. If we were doing 8 divided by 3, for example, we'd get a remainder of 2, and we'd put that over 3, so we'd get 2/3. It's exactly the same. We take the remainder and put it over what we are dividing by to get x minus 1. So we can rewrite f of x like that, and we see that remainder occur here. Okay, we see that remainder occur here. Okay, so this is just asking for the remainder. We've already said we don't need to divide this time to find the remainder. We can use this and the remainder theorem to find what that value will be. So I'm going to reveal both of these questions, and I'll give you about a minute to go through and have a go at both of those questions there. So just as a reminder, what we do on the, for example, on the left hand side is we can say, well, let's find f of minus 2. F of minus 2 will give us the remainder if we were to do this division. So that's the answer for the left hand side. For the right hand side, be very careful and just think carefully about what we're going to be substituting in to represent this bracket here. So we should be here substituting in f of a half. Right, the value of x here is going to be a half. So this is going to be 1/2 minus 5/2 plus 4, which will work out to 2. So we've got our two remainders here for both these questions, right? 11 and 2. And all we've done is, rather than doing quite laborious polynomial long division and dividing these big cubics by our brackets here, we've just understood that if we plug in f of minus 2 and f of a half respectively, we'll get the remainder that we would when we do that division. So we're just saving ourselves all that work. Okay? But this remainder theorem and factor theorem, they actually have a lot of applications. So we're gonna look at more applications and then go on some exam questions afterwards. But this is what we really mean. So I'll give you a second to read through this question on the left and get it copied out. So what we know from this information here is that f of 2 will equal negative 24. Right, that's what this statement, this first part of this statement is saying, that f of 2 will equal negative 24. So what we can do is then use that and say, well, f of 2 is equal to 2 cubed minus 2 squared plus 2a minus 8. So this is going to be 8 minus 4 plus 2a minus 8, and this is going to equal 24. And then this is just a simple linear equation to solve, right? To go and find the value of a. So I'll let you finish that question, and then have a go at this question on the right hand side as well. So that should be the value for a on the left hand side. I'm going to give you another half a minute to go through and find the value of a on the right hand side. If you've done that, then have a go at doing the second part of that question on the right hand side. So I'm just going to start writing up the first part of the solution to the right hand side question. So we should get that value there for a. Then we restate f of x. Before doing part 2. Right, it just makes it easier to restate it. And then part 2 is going to be working out f of 2. So we should get an answer here of 35 for that second part. Okay. So you can see actually this is similar to what we did previously, just the other way around. We're using that same knowledge, giving the remainder to find out some information about our equation or expression. So let's have a go at this one now. And this is again building on the same idea, just making it slightly more complex each time. And combining it with some of the stuff we looked at in topic 1. around solving equations and solving polynomials. So you can see here first, when we use the remainder theorem, we get two equations involving A and B. Now we should be understanding anytime we have two equations involving the same two unknowns, we need to solve them using simultaneous equations. So that, again, alarm bell should be going on ahead of how we're going to go about solving these equations. Now I'm going to rearrange this first one to make B the subject. And then substitute it in. And then you can find the values of A and B from there. Part B is then using the factor theorem. So if f of 3/4, if f of 3/4 equals 0, what will our root, you will know it's going to be something x minus something, what will our root be? And then for part C, we'll need to go through and either use polynomial long division or compare the coefficients to work out and solve f of x equals 0. And then once you've had a go at that one, there's this question on the right hand side, very similar, so you can have a go at that one as well. So this should be that we know plugging in 3/4 here, show that just means plug in 3/4 into here and show you get 0. But what it also tells us then is that 4x minus 3 is a factor of f of x. So B is just to show that question. I'm not going to go through that one. But I will go through part C. For part C here, come back to this one. I'm just going to check the question. I think there may be a mistake with the question. So go on to the second question here on the right hand side, work through that, A and B, and I'll come back to part C here in just a moment. Just give me a second to figure out what's going on there. So I made a mistake here. C should be minus 2 here. So my apologies. For this left-hand side here, C is going to be minus 2, which means we're going to get minus 8. 3 be minus 8 here. So you get minus 3b is equal to minus 9, and b equals 3, which makes much more sense. So, yeah, thanks Healy. My bad. Apologies for that. Thank you for spotting that. I got there a bit too late. So now we have f of x equal to 4x minus 3, and then 2x squared plus 3x minus 2x. Sorry, minus 2, not minus 2x, just minus 2. Minus 2. And this we can factorize. 4x minus 3. This is going to factorize to 2x minus 1 and x plus 2. So that's fully factorized. So therefore our solutions are 3/4, 1/2, and negative 2. Okay, very, very long question there, very, very long-winded question there. But have a go at the right-hand side question. From there. And I'll write up the solution for that in just a minute as well. So just to make sure you're along the right lines, I'm going to give you the values of A and B for the right-hand question. So A we should get 6 and B we should get negative 4. Part B for that is going to show that question. So I'll leave that out. And C, again, we've got one of the solutions thanks to part B. So we can go through and compare coefficients to work out the rest of the solutions. So I'll give you about another minute and then I'll start showing the working. I'm only going to show the working for part C on the right hand side on this occasion. Okay, so I'm going to start going through the solution to part C now. I won't explain it, I'll just write it up so you can follow it. So those are our solutions for part C there as well on the right hand side. Okay. So in case you've missed anything or just need some time to correct anything you need to, I'll leave that up there for just a couple moments, and then we've got a couple more slides to go through, and then we're done. So I reckon we'll get done probably somewhere around 1 o'clock, if not just before. So the remaining slides also are past exam questions. Today's session has been quite question heavy just because it's a very short topic, so I thought I'd pack a few more questions than normal in, just to get sure, just to make sure we're getting a lot of practice in. So let's have a look. So we've got 2 exam questions here. Let's go through the top one to start off with. So I'll give you about 2 minutes to have a go through that top one, and then I'll start writing up the solution for that, and then I'll reveal the bottom one after that as well. As always, if there's anything you want me to go through, if you get stuck anywhere, just write a comment in the live chat. I'm just going to start writing up the solution for question 1 at the top. In case you finish, I'll reveal question 2 at the bottom as well. So we've got parts A and B up there. And part C, remember, we're just taking the discriminant of this quadratic. So this is clearly going to be greater than 0, right? 49 plus 24 is going to be greater than 0. And it's not asking us to find the roots, it's just saying determine the number of real roots. Well, if this quadratic has 2 real roots, we've already got a real root here, we can say, therefore, 2x squared minus 7x minus 3 has 2 real roots, as b squared minus 4ac is greater than 0, and therefore f of x has 3 real roots. Okay. So, that question done. I'll give you another couple minutes or so just to start working through this bottom question here. We've got one more question left after this, and then we are done. We're done for the term. That's it. We are done for this term. Really great job from everyone. One thing I would say is if I've started explaining the question and you haven't quite finished the question yet, definitely make sure you pause the video, have a go and try and get yourself first, and then either when you finish or if you get stuck, unpause it and have a look at my solution and go from there. But make sure that you're really testing yourself, because that's how you're going to improve your understanding. So I'm just going to start going through part A here. One thing I want to note is it's really important you show this substitution that we've done here. The examiner wants to know that you understand what f of minus 3 or f of whatever number it is means, and you can represent it accurately. So it's really important that you show this substitution taking place here. So we've got part A finished down there for question 2. I'm just going to scroll this up. then part B is saying draw out this cubic, or sketch out rather this cubic. We need to make sure we mark on the key points. So we've got y-intercept at 12 here, and we've got roots at -3, a half, and 4. And this is a positive cubic, so it's going to look something like that. And then part C is a simultaneous equation question. Right? We've got intersection between 2 points, so we can set these two things equal to each other. 4x plus 12 is equal to 2x cubed minus 3x squared minus 23x plus 12. And again, we want to make this polynomial equal to 0. And you'll see the 12s cancel out. So left with a cubic that we can factorize out the x from. And then we can again go through and factorize the quadratic that we are left with. And this question thankfully only wants us to work out the x coordinates, so therefore we get our x coordinates as x equals 0, x equals 9/2, and x equals -3. So that's parts A, B, C, and C. They're done. Okay, so I'll leave that up for a second, just to you guys get familiar with it. We are coming up on 2 hours now, and it has been. It is a very, very nice hot day. There is one more question to go through, and then we can call it a day. So this is the last question. Well, I'm sticking with it, but this is it. This is the last question. So I'll give you some time to read through, get that done. If you need to shoot off, like I said, this question's available on our website. The slides are available on the website. Click on the link below and go to A-level resources. You can see these slides, or take a photo of the question. And if you want to have a go at it later and you get stuck, or you want to check your answer, send a photo either by email or by WhatsApp to the number in the description, and we'll get back to you. Otherwise, I'll give you some minutes to have a go at this question to start off with, and then I'll go through the solution, start going through the solution in about 3 minutes time. So I'm just going to start going through these solutions. Like I said, if you're still working, just pause the video here, get your working done, or get to a point where you think you've done as much as you can, and then watch the video and go back and press play. If we look at this equation on part 8 here, if we multiply out this equation here, we know we'll get a constant term of plus 4, so we have a y-intercept of plus 4 that we can mark here. And we've got solutions at 0 and a repeated root at x equals 2. I beg your pardon, we won't get a the y-intercept will be at 0. Y-intercept will be at 0. So our cubic is going to look something like this. So that's A done and B parts 1 and 2 also done. and also B part 3 done as well there. So part C, the quadratic part of this, again we're going to use the discriminant. The quadratic part of this gives a discriminant of -3, and we say therefore x squared minus x sorry, some technical difficulties. X squared minus x plus 1 has no real roots as the discriminant is less than 0. So therefore, the only real root of p of x is the one that's we've used previously here, which is when x is equal to 3, and we will just have to write that as a statement. Okay. So, like I said, if you need to pause the video here to correct or check any of your working, please do so. But otherwise, this is basically what we looked at today. So factor theorem and remainder theorem, the main bits, along with algebraic division and comparing coefficients to work out factors of polynomials and algebraic factors of polynomials. Okay. As always, stay safe and take care. Next session will be after the half term, so it will be a fortnight from today, 2 weeks from today. I hope you have a very restful and enjoyable half term. Please continue to go back and look through the old videos, like, share and subscribe, and follow us on Twitter and Facebook. If you have any questions in the meantime, please do get in touch either via email or WhatsApp and we will get back to you. But otherwise, take care and see you in 2 weeks. Thanks, Josh. You're most welcome. I'm glad you enjoy it. Great half term. You're welcome. Please take care. Thanks, Healy, Andrew. Enjoy your half term. Take care.